This week in lab we are doing sublimation. Let's first define what sublimation is. Sublimation is evaporation of a solid from a warm surface followed by condensation on a cold surface. Now what's important here is we are taking a solid and it's evaporating into the gas phase, never goes through a liquid. We want to heat it below its melting point. We do not want to melt it. We do not want a liquid. We're going to apply heat to it. It's going to go into the gas phase without passing through the liquid phase, and then it will condense back on the cold surface back into a solid. Now, previously we had done distillation. In a previous lab, when we did distillation, we took a liquid, evaporated from a warm surface into the gas phase, and then condensed it back into a liquid on a cold surface. So that's the difference between sublimation and distillation. Sublimation, you're using solid, never goes through the liquid phase. Solid to a gas, back to a solid. Distillation is liquid to a gas, back to a liquid. So that's our lab this week. Now let's talk a little bit about the procedure itself. This is a short lab. Well, it depends on which unknown you get. We are doing unknowns. If you're lucky, you get the right unknown, you'll be out really quick. If you happen to get the wrong unknown, you may be here a while. So we're going to use our sidearm filter flask. That's going to be your sublimation chamber. You'll put your impure compound. So sublimation is another way to purify. You'll put the impure compound in the bottom. You're going to put your centrifuge tube in, and you want the centrifuge tube to be about 1 centimeter from the bottom. Now, you use the little rubber ring here to put on the centrifuge tube to seal that. Let me show you how to work these. So try it. That's not 1 centimeter. I need it farther down. It's not going to help you to push. You can push all you want to. It's not going to go down. What you need to do is you have to work the rubber ring down. It's called working it. You push on one side, you turn around, push on the other side, turn around, push on the other side. Keep working it down. Working it down. You can apply this to a lot of things in your everyday life. Trying to get something on something, work it from side to side. Check it. Still not enough. Keep working it down. Push on one side, push on the other side. Oop, I went too far. So you want it about 1 centimeter from the bottom. pretty good. Now, so we have it about 1 centimeter from the bottom. On your sidearm, we don't want anything to escape, any of the vapors to escape out in the atmosphere. It's supposed to evaporate and then condense onto the centrifuge tube. This is called a cold finger. We're going to have ice in it in just a moment. Not yet. So we have our sample in the bottom, and we don't want any to escape into the atmosphere. However, we cannot heat a closed system. I can't have a closed system because then it can build up pressure as we heat, build up pressure, and it'll explode. So what we're going to do, we're going to solve that problem by using your pipette bulb. Mash it down to get all the air out, and then you're going to put the pipette bulb on that little sidearm. So here on the sidearm, you'll have your pipette bulb. So, as this heats up, if it builds up pressure, as the thing's going into the gas phase, you're going to build up pressure. But this bulb can expand a little bit, kind of like a balloon does. So that will keep anything from blowing up. We won't build up that much pressure because that bulb can expand a little bit and relieve that pressure. Now, once we have the sample in there, the centrifuge tube in, which we're referring to as a cold finger, pipette bulb on, then last you're going to put ice in. Make certain you do that last. We want everything sealed up before you put the ice. If we put the ice in before we have everything closed up and sealed, then you know how Mississippi is. We're so humid here that you're going to get condensation of water vapors onto the cold finger. So you've got to make certain that you have everything set up and put the ice in last. You'll take and just heat that. Now, I don't know what to tell you to put your sandbags on. I would start with a setting of, let's say 1.5. Let that heat for 10 or 15 minutes. Take a look. Nothing's happening. Turn it up a little bit. Maybe turn it to 2.5. Or let's say 2. Let's go take it up to 2. Start at 1.5, go to 2. Let it heat another 10 or 15 minutes. Keep checking it. Nothing's happening. Turn it up to 2.5. Doing about half settings of about half increments. We want to heat below the melting point. Well, you're doing unknown, so we don't know what the melting point is. That's why you need to slowly just keep turning the heat up until you see something happening. You should see crystals starting to grow off of the cold finger. You'll have little crystals growing here. There'll be crystals growing off, look like little hairs growing off of the cold finger. And if you see that starting to occur, don't turn up the heat anymore. Just let it sit there and go at the setting that you have it on, at the temperature that you have it. Now, the majority of your sample should sublime up. You should not be left with much at the bottom. What you're going to be left with are the impurities. Your pure compound sublimes onto the cold finger and leaves the impurities behind. I'll just go ahead and tell you the impurity that I contaminated it with is sand. You'll see little grains of sand there on the bottom of your flask. That's what I contaminated it with, was some sand. And it's not going to sublime. Now, once it has sublimed, take and carefully pour out all of the cold liquid that's in the cold finger. You can do that by simply turning it on its side, or you can take a pipette and suck everything out. Get all the ice and all the cold water out of the cold finger. Give it a few minutes to warm up. Once you get all the ice out, give it like 5 minutes to warm up. And then you can take this apart. Now you'll have to be very careful when you take it apart that you don't knock off all the crystals back into the bottom. Now when you do this, many of our crystals here, some of these are going to look like spider webs in here. Some of the crystals that look like spider webs. They're really fine crystals and they just grow every direction. Make certain that you've got a spot when you take this apart. Make certain you have a spot where there's no airflow. If you do these, I would not do these inside of your station, inside your hood, because I have seen these crystals are so fine, some of them are, I've seen them just get sucked up by the hood, especially if you get it too far back into the hood. I've seen them get sucked up. So try to find a spot where there's no airflow and just scrape them off on a piece of white paper. Get a piece of white paper, take your spatula, scrape them off, and you're going to calculate a percent recovery. You know how much you started with, you know how much you get out. Calculate a percent recovery, weigh that, calculate a percent recovery, and then get a melting point. Take that melting point and compare it to the table of unknowns and figure out which unknown you have. Now be certain you record your unknown number in your notebook. I can't grade it if I don't know which one you had, so make certain you write the unknown number down. It's on the vial. And then clearly identify which one you think it is. This is pretty easy. They've all got very different melting points. You shouldn't have any problems identifying which unknown you have. Okay, and there's no questions for this lab. Now, as far as your table of properties that I normally have you do, we've got so many compounds here, I'm not going to have you look all of those up. Just record that same table that I've got in the procedure, just the melting points. That's all we need this week is just the melting points. So you can record that as your table of properties. Just use just those melting points. You don't need molecular weights and densities and all of that this week. We'll get back to normal in the next labs. Okay, so that finishes what we're doing with sublimation. Now I told you I would talk about the lab midterm that is coming up, so let me give you a little bit of indication about kind of what to expect there. There's 20 questions on the exam, although some of them have several parts. So when I give you numbers here, I'm going to tell you how many questions I got on each lab. It's going to add up to over 20, and you're going to say, well, why is it that? But that's because some of them's got several parts. I have, let's see, we did, what was the first lab? We did extraction first. I've got 5 questions on extraction. Make certain you can do those calculations. So be able to calculate a KD, also be able to calculate, if you're given the KD and the solubilities, be able to calculate how much you would be able to extract with a certain amount of solvent. So those post-lab questions on that first lab, make certain you can do those calculations. I've got several of those questions. On the next lab that we did the acid-base extraction. I've got one question where you have to understand what we were trying to accomplish there. Do you really understand what's going on? But then I have 4 questions of acid-base reactions. Now they will be very similar to the reactions that we actually did in that lab. So look through those reactions, make certain you understand those reactions. I'm not going to have the exact same one, but it'll be something similar. So for example, we reacted with a base and then we acidified with hydrochloric acid. Maybe I put hydrobromic acid, HBr, instead of HCl, but it's going to work the same. So, I'll make little minor changes. It'll be very similar to those reactions, but make certain you understand those. I've got 4 of those on there where you have to give me the product. I'll give you the starting materials and you give me the product of the acid-base reaction. Let's see, which lab did we do next? I'm trying to think. So I guess we did distillation next. I've got one question on distillation. Well, 1.5 on distillation. It is part of another one as well. So I'll say 1.5 questions. Make certain you understand, what we were trying to accomplish there with the distillation. Understand that theory. We did a simple distillation, we did a fractional distillation, know the difference in those. With the distillation, we also talked about boiling points. I have one question on boiling point. You know the question I have on boiling point. I've told you it's how relate the structure to the boiling point. So I'm going to have 4 compounds and say put them in order of increasing boiling points. So you use that structure to determine which one has the lowest boiling point and which ones have the highest, and put them in order. Put the 4 compounds in order. So that's a question on boiling points. We did recrystallization. I've got 2 questions on recrystallization. Make certain you look through, the theory that I went through. Know what your criteria are for a good solvent choice, those type things. So I've got 2 questions on recrystallization. With recrystallization, we also discussed melting point. I've got 4 questions on melting point. Now, one of them is how the structure relates to melting point. So I'll give you 4 compounds and say put them in order of increasing melting points. So we went through how the structure affects the melting point. The other questions, just make certain you know the theory behind melting point. Make certain you understand about the melt temp that we use to measure the melting point, how that works. What effects impurities have on the melting point. Make certain you can do those post-lab questions that I had on that lab. I may ask something about some of those. And then this week we're doing sublimation. I've got 1 question on sublimation. Don't forget safety. We did safety the very first day. I could definitely ask a safety question. So make certain you look through that. I do have 1 question where you have to apply what you've learned. So I've got a real world problem. So all of these labs that we've done up to this point have all been purification labs. We've been able to separate compounds and purify those. Make certain you understand what each lab was purifying. For example, distillation. Did it purify a solid? No. That was to purify liquids. So make certain you understand what you were purifying, how it worked, and then you can apply that to a real world problem. I've got 2 questions on some compounds that we used in multiple labs. There's a couple things that we've used in multiple labs. So there are a couple of little easy gimme questions. So that's pretty much what you can expect as far as the number of questions on each thing. Just look through the notes you took from my pre-lab lectures. I answered everything is in my pre-lab lectures. I'm not asking you anything that wasn't in those. Okay, I think that's it.